All right, so a practice video to help you in using the law of sines. It's important when you start any of these oblique triangle problems, so a triangle that does not have a right angle, that you consider what was given to you. We know we can use the law of sines when we were given an angle, a side sandwiched in between, and another angle, or when we were given two angles and a side not included in between those two angles. For right now, those are the only two situations that we've come across because we're just doing the law of sines today. But we will eventually learn about something called the ambiguous case, and we will learn about what happens when you're given three sides or two sides and an angle sandwiched in between. So to start with this one, I was given a side, I was given this angle, and I was given this other angle. So I've got an angle, and a side dot sandwiched in between. So angle, angle, side, which means I can use the law of sines. First thing you want to do is find your last angle. So hopefully you are okay with the fact that angle C is going to be 38 degrees because you subtract from 180. And then you want to figure out what angle and side pair do I have that I can start my ratios. Well, I know that 20 is across from 34. So 20 over the sine of 34 will be my ratio that I set up to use, because that's a good angle side pair. And then that will allow me to find side B and it will allow me to find side C. That one was 38 degrees that we found. So I'm going to do a little bit of solving of a proportion using some multiplication, and I will end up that B is equal to 34 centimeters and C is equal to 22 centimeters. And again, you can think about the reasonableness of your answer. Angle B was 108 degrees. That's by far our biggest angle because it's the obtuse angle. And 34 is definitely our biggest side. 34 was our smallest angle. That one had a side of 20, our smallest side. All right, question 3. I was given this angle, this side, and this other angle. So I have an angle right next to a side squished between another angle. So this would be angle, side, angle. First thing I want to do is find that missing third angle. So angle C ends up being 55 degrees. From there then I want to figure out which angle and side pair do I have. Well, I have 55 and 24, so I'm going to use that as my basis for the ratios that I'm going to be finding. So 24 over sine 55 for both of these. And then I still need to find what's going on across from 82. And I need to figure out what's going on across from 43. So again, we're setting up these ratios, and I'm going to use some multiplication to solve them. I end up with B is equal to 29 kilometers and A is equal to 20 kilometers. Okay, so those are your first two examples. Again, you should do the number crunching in your calculator and make sure that you can get those values, because the next two you are going to try on your own and then pause the video. So I'll help you get started. Again, you want to mark I have this, this, and this. Think about what type of triangle that is. On this one I have this angle, and this side. So go ahead and set up your law of sines for each one and then see if you can work all the way through. Find your missing angle and your missing two sides that you need, and then unpause your video when you're ready to look at the answers. Okay, but really you should pause your video and you should try these two on your own, because if you just write down what I'm doing, you're going to get stuck when it comes time to do your homework. Seriously, pause your video. Okay, so go ahead and check your answers. Look at the ratios that I chose and how I set things up, and then look at the values for the final answers. I want to talk real quick about this over here, because when we talk about the biggest angle on the biggest side, so 117 degrees is across from 21.4, and then we had 61 is across from 21, and then we had 12 is across from 5. And you're probably thinking, well, Ms. Schwartz, the 117 is way bigger than 61. but 21.4 is not that much bigger than 21. And I agree with you. But if you think about how a sine value works on the unit circle, that unit circle, it's always coming back. So within a unit circle, 61 degrees is about here. And 117 degrees is definitely past 90, but then we get to about here. So the reference triangle that I would draw in, right, 117, well 180 minus 117 to get my reference angle is 63. So when we're talking about the sine value or the y value for each of those angles, they actually are pretty close in their heights, which is why these sides then come back pretty close in terms of their numerical value. Now, again, it's because things are not just directly 117 is that much bigger than 61, so the side is that much bigger than the one across from 61. You have to consider what's happening in the right triangle that's built in to the oblique triangle, which again, there's a YouTube video posted if you'd like to get more about where the law of sines comes from.